Good morning, friends. I hope everyone is doing well. I request everyone to watch my videos in a sequence for better understanding. If you really like my teaching and my efforts, please press the like button, share the videos with your friends, subscribe to my channel, and also press the bell button to get the regular updates. In this video, I want to discuss about the parallel adder and subtractor. First, let me define what is the parallel adder and subtractor, and then I will discuss the combinational circuit and its working process. All these things I will discuss in detail. So I request everyone to watch the complete video for better understanding. Let me define what is a parallel adder and subtractor. It is a combinational circuit capable of both addition and subtraction of binary numbers. Now let's take that we have two binary numbers A and B. They are 4-bit numbers. Now A0, A1, A2 and then A3. Then we have B0, B1, B2 and B3. Now if you want to perform the addition or subtraction, we can use a single circuit. Is it clear? Suppose if I want to perform the addition, A0 and B0, what I will do? I will perform the addition. I will get the sum and the carry. Again the carry, A1 and B1 will be performed addition. I will get the sum, carry, okay, and then I will get the sum and the final carry I will get. Am I right or wrong? Now using addition, we can perform the subtraction also. How I can do it is, let me discuss it for you. Okay. Now what I will do is that A minus B can be written as A plus minus B. Am I right or wrong? Now this minus B is nothing but the 2's complement of the B. I have the B. I will compute the 2's complement of the B. Okay, what is 2's complement? First I will find the 1's complement of the B and I will add 1 to it. I will get the 2's complement of the B. The 2's complement of the B is nothing but equal to minus B. Are you able to understand? So minus B I will get, then I will perform the addition. Is it clear? Are you able to understand it or not? So what I will get? I will get the A minus B only. So using the addition, we can perform the addition, and if you want to perform the subtraction, you find the 2's complement of the B and perform the addition, you will get the subtraction A minus B. I hope you have understood. Now with this principle, they have constructed a combinational circuit which will perform the addition and also the subtraction. Now if you have n-bit numbers, if you want to perform the addition and subtraction, addition or subtraction for n-bit two binary numbers, then you need n full adders. In this example, I want to perform the subtraction between A minus B or A plus B, which are 4-bit numbers. So I have taken the 4 full adders. So based on the length of this bit, you need to take the full adders. Is it clear? I hope you have understood. Now let me discuss the next important point. Okay, now if you see the combinational circuit, we have A0 and B0, A1, B1, A2 and B2, A3 and B3. And you have the M, and you have the C0, C1, C2 and C3, and you have finally the C out. Now whenever we want to perform the addition, either you want to perform the addition or subtraction, that will be depend on this M value. If M value is 0, let me write this one. If M value is 0, this circuit will perform the addition. Okay. If the M value is 1, it will perform the subtraction. Okay, I hope you are following it. How it is when M is equal to 0, how it will perform the addition. When M is equal to 1, how it will perform the subtraction, I will discuss. Is it clear? And if you can understand or identify from the figure, this is an exclusive OR gates. Okay. Now let me tell, if M is equal to 1, how it will perform the subtraction. Now what is this exclusive OR is taking? It is taking the B0 and M value. Let's take that if M value is 0, Okay, and you have the b naught. What will happen if you give this b naught and 0 to the exclusive OR gate? It is 0 exclusive OR b naught. Am I right or wrong? What it will perform? 0 and b complement, or 0 complement and b naught. Why it so? A exclusive or B can be written as A B complement or A complement B. So here my A value is 0, my B value is B naught. So 0 and B naught complement, or 0 complement and B naught. Now 0 and with anything you will get 0. Will you agree with me or not? Then you have R, 0's complement is 1, and you have B naught, which you will get it as B naught only. Is it clear? I hope you have understood. Meaning is that when M is equal to 0, the exclusive OR gate will give you the B naught. So A naught and B naught you are giving to the full adder. So it will perform the addition only. Is it clear? When M value is 0, because each one is given the M value. So if M value is 0, all these values will become 0, and B1 exclusive OR with 0, you will get B1. B2 exclusive OR with 0, you will get B2 only. Are you able to understand? When M is equal to 0, it is just performing the addition. Now we will see when M value is 1, how it will perform the subtraction. When M value is equal to 0 and you have the B naught here, if you perform the exclusive OR between M and B naught, M value is 1 exclusive OR with B naught. Just now we have discussed the expansion of exclusive OR, which is equal to 1 and B complement, or 1 complement and B naught, which is equal to 1 and B naught complement. Am I right? Just you write and. Okay. 1's complement is 0, 0 and B naught, which is equal to B complement naught, meaning is that B naught complement, because this one entire one will be 0, 0, or you can write it 0 or B naught complement, which is equal to B naught complement. So when M value is 1, you will get B naught complement, B1 complement, B2 complement and B3 complement. Will you agree with me or not? Now we got the B complement, but what I said, we should have the 2's complement we have to find for the B. 2's complement of the B is equal to 1's complement and R1, meaning is that if you want to find the 2's complement of any binary number, first you need to compute the 1's complement and add 1 to the LSB of the 1's complement. Then you will get the 2's complement. Now if you see that we got the 1's complement of the B. B naught complement is nothing but the 1's complement. And when M is equal to 1, your C naught is equal to 1. Am I right or wrong? So which is equal to this one, A naught, B naught complement, and 1 you are giving to the full adder. Full adder is capable of performing the 3 addition, meaning is that 3 bits we can perform the addition. So which is nothing but A or B complement or 1, because C naught is also 1. Now which is equal to A, or you have the minus B, which is in 2's complement form. So you are performing the A minus B. I hope you have understood. Is it clear or not for you? So if you have a doubt, let me discuss with an example. You want to perform the 6 minus 3. Is it clear? You want to perform the 6 minus 3. So what you will do is that you will compute the 3's 1's complement and add 1, then finally you will get the 2's complement. So first what we will do is that we will represent the 6. What is the 6? Which is 1 1 0. And remember one thing, this is plus 6. So you will have the sign bit as 0. Are you able to understand? This is the sign bit and this is the actual decimal number which is represented in the binary number. Now you need to find the minus 3. So first, how you will find the minus 3 in 2's complement? First you will represent the plus 3. Plus 3, how I can represent in 4 bits? 0, 0, 1, 1, which is equal to, this is sign bit and this is the value 3. So now what you will do is that you will find the 2's complement. How you will get the 2's complement is that first you perform the 1's complement. What is 1's complement? If input is 1, output will be 0. If input is 0, output will be 1. So which is 1, 1, 0, 0. Add 1 to the LSB. You will get 1, 1, 0, 1. Is it clear? So you are getting 1, 1, 0, 1. Now you perform the addition. 0 and 1 is 1. 1 and 0 you will get 1. And 1 and 1 is equal to 0 and 1. 1 and 1 is equal to 0 and 1. Are you able to understand it or not? If you are performing the addition 1 and 1, the sum will be 0, carry will be 1. The same thing I have applied. 0 and 1 is equal to 1. 1 and 0 you will get 1. 1 and 1 you will get sum as 0, carry as 1. And 1, 0, 1 is nothing but sum is 0, carry is 1. Whenever we want to perform the 2's complement addition, if you get the end carry, we will neglect it. Am I right? So now what you got? 0, 0, 1, 1, which is equal to plus 3. Will you agree with me or not? So this is the way we perform the subtraction. So if m value is 1, it will perform the addition. If m value is 1, it will perform the subtraction. If m value is 0, it will perform the addition. Is it clear? I hope you have understood about what is the parallel adder and how this combinational circuit is working. If you still have any doubts related to this concept, feel free to ask me in the comment section. I will try to clear your doubts in less than 24 hours. Thank you for watching my video. Have a nice day.